In this video, I want to have a look at exact values. So when we're using trig and sine, cos and tan, often we'll put sine or cos or tan of an angle into our calculator and we'll get an approximation as our answer. But there's a few values where we can know what those ratios equal exactly. And we're going to have a look at how to derive those and what they are. So let's start off by looking at this isosceles triangle. So because it's a right-angled isosceles triangle, that means that both these angles are 45 degrees. We've also chosen this right-angled triangle so that each of the equal sides has a side length of 1 unit. So to start off, I just want to find the length of this side here. So if we call that x, we can use Pythagoras' theorem. So x squared will be equal to 1 squared plus 1 squared, which is just 2, which means that x would be equal to the square root of 2. So this side here is equal to the square root of 2. It's root 2 units long. So now that we know all three sides, we can find the values of sine 45, cos 45, and tan 45. Now it doesn't matter whether we go from this angle or this one, because they're both 45 degrees, we're going to end up with the same answers. So sine 45, we know that sine is opposite over hypotenuse. So from this angle, our opposite is 1 and the hypotenuse is root 2. So sine of 45 degrees is going to be 1 on root 2. So this is its exact value. If we were to type sine 45 degrees into a calculator, we'd get a decimal as our answer and it would just be an approximation. But this is exact. Now cos of 45 degrees is equal to the adjacent over the hypotenuse, so that's 1 over root 2. So sine of 45 and cos of 45 are exactly equal. And our last one is tan of 45 degrees, which is the opposite over the adjacent, so 1 over 1, which is just 1. Okay, so there are three of our exact values. Sine 45 is 1 on root 2, cos 45 is 1 on root 2 as well, and tan 45 is 1. Next, I want to have a look at an equilateral triangle. So because it's equilateral, every angle in that triangle is 60 degrees, and we've chosen this so that each side is 2 units long. So using this triangle, it's not a right angle triangle yet, so we can't use our trig ratios. But what we're going to do is we're going to drop a line straight down from this vertex to meet this bottom line here. So if we drop that straight down there, it's going to meet at right angles. And because it's an equilateral triangle and we've dropped it straight down, it's going to bisect this angle at the top. So that means it's going to cut it in half, which means that this bit here is now 30 degrees. Okay, so I've just rubbed out the half of the triangle that we're not interested in, but we now have a right angled triangle with an angle of 30 degrees and an angle of 60 degrees. Now this length, this side across the bottom here, because we chopped our triangle exactly in half and the whole bottom edge was 2 units long, that means that this edge here is going to be 1 unit long. We need to also find the length of this vertical side here. Using Pythagoras' theorem, if we would call that x, we'd have x squared plus 1 squared is equal to 2 squared, because that 2 is the hypotenuse. So that means that x squared is going to be 4, because that's 2 squared minus that 1, which would be 3. So x, that side, is going to be root 3 units long. So we'll just rub that out and replace that with a root 3. Okay, so now we have a right angled triangle. We know both all the angles and we know all the side lengths. So now we can have a look at our ratios. Let's start off looking at the ratio of 30. So if we have sine 30 degrees, sine is opposite over hypotenuse, so that's going to be 1 over 2. Next is cos of 30. Cos of 30. So cos is adjacent over hypotenuse, so that's going to give us root 3 over 2. And the last one is tan of 30 degrees, which is going to be opposite over adjacent. So in this one, that's 1 over root 3. Okay, so that's all our ratios for 30 degrees. Now let's have a look at this 60. So sine of 60 degrees is equal to the opposite over the hypotenuse, so root 3 over 2. cos of 60 degrees is equal to the adjacent over the hypotenuse, so that's 1 over 2. And tan of 60 degrees is equal to opposite over adjacent. So that would be, from this 60, opposite is root 3 over 1, but root 3 over 1 is just going to be root 3. So we've got sine, cos and tan of 30 degrees and sine, cos and tan of 60 degrees. So you do need to remember all 9 of these values. So we've got sine, cos and tan of 30 degrees, 45 degrees and 60 degrees. You kind of have two options. You can either just memorize this table and the values, or you can remember the two triangles that everything was based on. If you remember those two triangles, then you can always figure these out again. There are a few patterns to help you though. So if we go sine and we go down the list, we've got a half, 1 on root 2 and root 3 on 2. And if we go up this one, we've got cos of 60 is a half, and then cos of 30 is root 3 on 2. So going down this column is the same as coming up this column. So they're just in reverse. So that means really you only have 6 values you need to remember if you remember that pattern. Okay, so that's just a quick look at exact trig values.